Hello, grade 12s. You are welcome to Academic World. Let's continue with your interesting assignment, Mathematics grade 12, assignment number 1, 2025. We are now continuing on question 2. We are looking at 2.2. Very, very important to read your information whenever you are working with Euclidean geometry. But let me say it's always important, whether it's Euclidean streak, reading information, it's always important. So we're going to read the information. Let's go straight to the reading of the information. In the diagram below, I'm reading the information on 2.2. In the diagram below, P is the midpoint of AC. Let's stop there. P is the midpoint of AC. So they are simply saying P is exactly at the middle of A and C, meaning that the distance from A to P is equals to the distance from P to C. Remember, we are saying P is the middle point. P is the midpoint. So if I have a line like this, let's say I have a point A here and I have point C here, and I say here I have P, and I say P is at the middle. So it means that the distance from P to A, let me call it PA, is equals to the distance from P to C. Okay. Now, if we go back to your information on the assignment, just because they said P, let me annotate here, just because they said P is at the middle of A and C, it means that AP is equals to PC. And we should keep this information with us. We might need it when we are solving the problems in this question 2.2. So we know that AP equals to PC. Let's continue with the reading of the information. They are saying R is a point on AB. And it is true. If you look at this point, R is on the line AB. R is a point on AB. Okay, such that RS, so let us see RS, such that RS is parallel to BP. RS, BP, so these two lines are parallel. This RS is parallel to BP. Okay, just because they said RS is parallel to BP, this brings forth something of a very, very, very important. I don't see this one not coming in your exam. What I'm going to talk about is proportionality theorem, and it is very rare that prop theorem will not be there in your exam. So you can write down on your books, prop theorem, I'm saying, is going to come. Write this one down. Proportionality theorem, it has to be there in your exam. So they said RS is parallel to BP. I want us to look at this triangle A, B, P. This triangle here. I'm trying to, yes, show it with a red color ink. So I have let me say A here, just if you don't see, B here, P here. You look at this triangle ABP, it has got three sides. Obviously, triangle must have three sides. But I want to take your attention to the side BP. And also say again, look at this line RS. Pay attention to the side BP and look at the line also RS. The line RS is parallel to one side of a triangle. I said triangle has got three sides. The line RS is parallel to the side BP on a triangle ABP. Now, because we have a line drawn parallel to one side of a triangle, proportionality theorem can be very useful. Grade 12s, every time when you see a line drawn parallel to one side of a triangle, you have to take this one into account. Proportionality theorem might be very important when you are solving the problem. So what am I going to do here? I see that RS is parallel to BP. So let us leave these two guys that are parallel and check the side of this triangle ABP, but not focus on the side BP. So we have this side, AB, the side AB, and we have the side AP. If we exclude a bit, the side BP, which is parallel to RS. Now we are going to say those two sides of AB and AP are in proportion. Actually, I'm going to explain what I'm talking about here. The prop theorem will work like this. We are going to say, let's take the distance from A to R. So we say AR. You can even say AR over RB, the distance from R to B. So you can say AR over RB equals to AS over SP. This is applicable. This is prop theorem actually. This is applicable because the line RS is parallel to the side BP. So when you see parallel, lines that are parallel, and you see a triangle there, think of a prop theorem. So you have a right to say AR, there is R here, this is R here. So you have a right to say AR over RB equals to AS over SP, or you can apply prop theorem differently. You can say AR, this is mathematically acceptable, AR over AB equals to, I said AR over AB. Now I'm going to say AS over AP. The reason is still prop theorem. You can apply, here I'm exposing you that this prop theorem, you can apply differently, and how you apply it will depend on the information which has been provided on the question paper. So we have got two possibilities. We can say AR over RB equals to AS over SP, or we can say AR over AB equals to AS over AP, or we can also look at the different way of applying prop theorem. Maybe you can even say RB over AB. What you do to that side, go and do it on the other side. Just follow the same procedure. So I started with RB. It means on the side of AP, I will start with SP. So I will say SP over AP. Just know that this prop theorem can be applied differently. How we apply it depends on the information which has been provided to us. So, okay, I was just introducing you to the idea of a prop theorem. I've not yet started solving any of this question, 2.2.1, 2.2.2, 2.2.3. I've not yet started attempting the question. I'm just explaining mathematical ideas that comes from the diagram. Okay? Now let's go and solve the problem actually. Let us try to find AS over SC. Okay? I want to find AS over SC, but before we even calculate this AS over SC, it is very important to look at the information which the examiners has provided, because the information which has been provided is a guideline on how you solve the problem. Take the information which is provided into account. So we are told here that AR over AB equals to 3 over 5. Okay, AR over AB equals to 3 over 5. So I will say this AR over AB, AR over AB equals to, I'm applying prop theorem. So on this side of AB, I started with AR, which is on top. So it means that on this other side, I will start with AS. So I will say AS over, take into account, I set AR over AB. AB is this long distance from A to B. So I'm going to take now the long distance from A to P. So I will say AS over AP. And I have to give a reason why I'm saying AR over AB equals to AS over AP. My reason is prop theorem. My reason is prop theorem, proportionality theorem, and you have to show us the lines that are parallel, state parallel lines. RS is parallel to BP. Okay, AR over AB, it has been given to us that is 3 over 5. And we are saying this AR over AB equals to AS over AP. So since AR over AB is 3 over 5, it is provided on your question paper. AR over AB, they said it's 3 over 5, which means that also AS over AP is 3 over 5. So AS over AP is equals to 3 over 5. Did I solve the problem of 2.2.1? No. 2.2.1, they are looking for AS over SC. But what do I have? I have AS over AP. I know that AS over AP, it's 3 over 5. What does the examiner want? AS over SC. So I don't have to stop with AS over AP. I have to come with ways of finding this AS over SC. Don't worry. Don't worry. I'm here. Just move with me. Make sure that you are following. Make sure that you understand. How do we find this AS over SC now? I'm going to say, guys, we set AS over AP. It's 3 over 5. So I will say this AS, it's 3. No, that is wrong, sir. AS is not actually 3 because we are not given the true length of AS. But I'm going to represent this AS in terms of this 3 and a variable. So I will say AS is 3x. Represent it in terms of a variable. Now, AP, the AP, I'm going to represent it in terms of a 5 and a variable. So if AS, let me show that one with a red color here. If AS is 3x and the distance from A to P, I want to represent it in terms of 5x. It means SP is 2x. So that 3x plus 2x will give me 5x. So I'm saying the AP, this is what we call, I think it's a line, line segment addition postulate. Yes, line segment addition postulate. So we are saying the distance from A to P is the sum of AS plus SP. And don't forget, I'm saying this AP, I'm representing it in terms of 5x. So AP, I'm representing it in terms of 5x, and I represented AS with terms of 3x. Surely, this SP, you can tell that it has to be 2x. So that's why I'm saying the distance from S to P, I'm representing it in terms of these two and a variable. Some of you are confused. Some of you want to say AS is 3, SP is 2. Wrong maths. You are not told the true length of AS. You were given what we call a ratio. So we don't have the true measure of the distance of AS and SP, but we can represent this in terms of some variables. So now the distance from A to P, I'm representing in terms of a variable. I'm saying it's 5x. I said AP can be considered to be 5x. Remember, I said AX can be seen as 3x. AP can be seen as 5x. So which means that PC, the distance from P to C, I'm going to see it as 5x as well, because I know that AP is equals to PC. AS is equals to PC. I'm representing PC now as 5x because I represented AP as 5x. And we know that AP equals to PC. Do not forget, we were told that P is the midpoint of AC. So if P is the midpoint of AC, it means that the distance from P to A is the same as the distance from P to C. Now, it's easy to know this AS over SC. AS pre-X SC, the distance from S to C, I said SP is 2x, PC is 5x. So SC, this is a line segment addition postulate, guys. Don't forget this. Line segment addition postulate. So we are saying the distance from S, let me use a different color. The distance from S to C, it's actually is the sum is SP plus PC. Line segment addition postulate. So we are saying SP, which is 2x, plus PC, which is 5x, which makes the distance from S to C. I'm going to represent it in terms of 7x. X cancel X. So the answer is 3 over 7. Which means that AS over SC, it's 3 over 7. So you found the value of the ratio AS over SC. Practice makes perfect. Do not be discouraged mentally. You guys need to put effort. Please try to understand how I come to the conclusion that AS over SC is 3 over 7. You can do these things with understanding. Don't just pick the answer. I know some students, learners, they're interested on picking the answer. No. Understanding. Remember, the reason we are bringing this assignment is for you to learn. So now, let us find RT over TS. I'm now working on the problem 2.2.2. RT over TS. Okay, I will say to you, pay attention to the triangle RSC. And do not forget that the line RS is parallel to the line TP. Yes, remember they said the line RS is parallel to the line BP. And the line BP is the same line TC. Actually, the line TC is a portion, it's a segment of BP. So if RS, R it's here, S is here. If RS is parallel to BP, B is here, P is here. If RS is parallel to BP, automatically RS is parallel to TC. That is the same line. The line BP, I mean the line, yes, BP is the same line TP. So RS is parallel to TP. These two lines I've identified with the red color. RS is parallel to TP. Now I will apply prop theorem. They are looking for RT over TC. So I will say RT over TC. Watch out. Look for what I'm doing. I'm saying RT over TC. What I'm doing on this side, I have to go and do it on the other side. So on this side of SC, yes, SC. So I set RT, yeah, there is T here, guys. I set RT over TC equals to, I'm going to say RT over TC equals to, just because I started with this small portion here, this side also I will start with this small portion. So I will say SP over PC, and I will say prop theorem. I have to name the lines that are parallel. In this case, it's RS, which is parallel to TP. You can still say RS is parallel to BP. I think it's acceptable. So we are looking for RT over TC, which we know that is equals to SP over PC. And SP is 2x. Don't forget this portion here. This SP here, this portion SP here, we represented it in terms of 2x. And then PC, we represented it, this PC, we represented it in terms of 5x. So we are saying SP over PC. SP is 2x. PC, it's 5x. So I have a right to say RT. Why can I write? Sorry. RT over TC equals to, my SP is 2x. My PC is 5x. So actually RT over TC is 2 over 5. RT over TC is 2 over 5. It was simple. You just have to apply prop theorem there. Let me erase. Okay, let me erase everything. I just want to erase everything. And then let me put the question paper a bit like this. Yes. So now they want us to find, the area of RAS. I will call it RAS, the area of triangle RAS. They're looking for the area of triangle RAS over the area of triangle RSC. So let us look at these two triangle RAS. And this triangle RSC. So this triangle RSC. These two triangles. So they are looking for the area of the triangle RAS over the area of triangle RSC. Now, actually, this is 2.2.3. I'm going to solve 2.2.4 first, and then I will come to 2.2.3, because the main aim of doing this video is for you to learn. And there is something which is very important, which I want to explain on 2.2.4, which will make the problem of 2.2.3 more easier. So don't be surprised. I'm going to start with 2.2.2.4 and then go to 2.2.2.3. But before we move to 2.2.4, if you look at the two triangle RAS and RSC, RAS and RSC, they don't have what we call a common angle. Some triangles have got a common angle. Some triangles, they share the same angle. Let me show you those two triangles that share the same angle. If you look at the triangle TPC, which is the triangle from the problem of 2.2.4, TPC and RSC, and RSC, and RSC, yes. Yes. If you look at these two triangle, TPC represented with a red color and the triangle RSC, they have a common angle C. They are sharing this angle C. This angle C, it is found on a triangle TPC and it also found on a triangle RSC. So the triangle RSC and the triangle TPC, they are sharing the same angle. So don't panic when you see this kind of problems in Euclidean geometry. There is a high, the likelihood is very high that you will meet it in your exam, this kind of a problem, where we want to know the area of one triangle divided by the area of another triangle. And when we look at these two triangles, they are sharing the same angle. They have got what we call a common angle. And TPC and RSC are good example of those triangles I'm talking about if you look at the diagram of your question paper. Now, how do we solve this problem of 2.2.4? I'm looking at 2.2.4. How do we solve it? Let me write 2.2.4. I'll come back to 2.2.3. Don't do this in your exam. It's not healthy unless you are clear of what you are doing. It is not healthy to leave 2.2.3 and go for 2.2.4. It's especially in Euclidean geometry, it is advisable to solve the problems in their given order. So let's go for 2.2.4, the area of TPC over the area of RSC. So I said the triangle TPC and RSC, they are sharing the common angle. They are sharing angle C. So I'm going to see, focusing on the triangle TPC now, I'm going to see the angle C as the included angle. My included angle, to me, when I'm referring to the included angle, I'm referring to the angle which is between two known sides. So I'm going to say, let me focus on the side PC. Maybe let me show you an example somewhere. Let me draw the diagram somewhere here. Let me draw here ABC. So if I give you the side AB and says 2, and give you the side AC, it's 3. The angle between these two sides of focus, the angle between the side AB and the side AC, it is going to be my included angle. So if I'm focusing on a AB and BC, this B will be my included angle. So I want you guys to identify the angle between two sides. So in this case, I'm going to say, see the side P, this is P here, C, and the side T, C, these two sides, and consider this angle C as the included angle. So if you do this, you will be able to calculate the area of a triangle TPC using what we call area rule. According to the area rule, you are going to say half of, you take those two sides where you want to put your attention to. In this case, is the side B's, PC and TC. So you say PC, TC, and then you say sine angle C. Sine angle C. That is the area of TPC. Now you are going to say, let me go for the area of RSC. RSC, RSC. So we're going to see RC. I want us to look at the side RC. Sorry, the side SC, that is SC, and the side RC. So I'm going to say, okay, this triangle, let me raise everything actually so that we focus on this triangle so that you can see it very clearly. The side RSC, this triangle. And I also want to see, I want us to see this C as the included angle. I'm using, because I've noticed that the two triangles, they share the same angle C. So I'm always using the angle C as the included angle. So now I'm going to say the area of this triangle RSC is going to be half of RC SC sine of the included angle. So now let's see what happens after doing this. We see that this guy cancel this guy. Half cancel half. So we are left with what? I'm going to write somewhere here, guys, on top. Let me remove this so that it does not confuse you. We are left with PC. Okay. PC over RC. Okay, PC times TC, this is what is left. PC times TC over RC times SC. After cancelling out, we are left with PC times TC over RC times SC. Now, okay, as we continue solving this one here, I want you to go back to C, just to see 2.2.2. On 2.2.2, we had something like RT over TC. RT over TC. I thought that might be very helpful, but let's see. I cancel those two, so I'm left with, but I did pick the right angle, so I'm just checking where I might have PC, TC, sine C. That was a good idea. RC, SC, sine C. That was a good idea. So I have PC over PC times TC over RC times SC. So RC TC. I want you guys, look, I'm going to write this differently. I'm going to say this is TC. This is the same as TC over RC times PC over SC. So I just focused on these two and also observed these two. What motivates me to do this? I will explain. Okay, this TC and TC and RC, they are coming from this side of a triangle. RT, this TC, if you look, TC is this guy here. TC is this guy here. The distance from T to C. This is TC. And then RC is this guy. It's from R to C. Is the big, is this distance from R to C. So that is why I'm putting TC and RC together. They are coming from the same side. They come from R. If you observe from R to C, you can see TC, you can also see RC. And if you observe from this side now, if you observe from this side, you can see this PC and SC. That is why surely I've placed them together. Okay. So let's continue on our problem. Let's continue. So how do we solve this TC over RC times PC over SC? Now look, TC, observe carefully, TC over RC. And observe on the other side, observe on the other side, we are having PC SC. And if we apply proportionality theorem focusing on this triangle, you will see that actually TC over RC is actually equals to PC over SC. This is proportionality theorem. You might not get this one, guys. Please take your time and observe carefully on a triangle RSC. You will see that actually TC over RC is equals to PC over SC if you are applying proportionality theorem. So since these two guys are equal, you can, okay, let's say RT, let's just state this, TC over RC equals to PC over SC. Give a reason, prop theorem, and you must also name parallel lines there. So now because this guy equals to this guy, these two guys are equal, I'm going to write one of them twice. So I can say PC over SC times PC over SC. So where I see TC over RC, I can just write PC over SC because they are equal. Now I'm going to have PC over SC being squared. PC over SC being squared because it's PC over SC times PC over SC. So it's PC over SC being squared. So now, what do I know about this PC over SC? It's just we raised our values. AS, we had set it's 3x, and SP, we had said it can be represented by 2x, and PC, we said it can be represented by 5x. So if you are looking for PC over SC, PC from what I've just written here, PC is denoted by 5x. So I can say PC, it's 5x. What about SC? SC, it's 7x. Then you square. Remember, that should be squared. But we know where x actually cancel x. So the answer here is 5 over 7 squared. I believe it's 25 over 49. Just press your calculator. Just press your calculator. So I'm going with 25 over 49 on 2.2.4. Make sure that you understand 2.2.4. Your assignment is looking very good. It's a good resource to make use of for your final exam as you prepare for your final exam. I assume you are now currently preparing for June exam. This assignment is a very, very good resource. Practice this assignment. Make sure you understand everything on this assignment. If you practice this assignment and you understand, most likely you are passing. You are passing your maths. So let's go back to 2.2.3. 2.2.3. Actually, I think this 2.2.3, it has been given less marks. I think it was supposed to be, the marks there were supposed to maybe at least say 3 or maybe 4. I don't think it deserves this less marks. So let us look at this area of triangle RAS over RSC. I will say 2.2.3. So I'm going to look at the area of triangle RAS over the area of a triangle RSC. RSC. I have got A here, I've got R here, I've got C here. What I will tell you guys now is that these two triangles, ARS and the triangle RSC, they are segment inside the triangle ARC. These two triangles, actually, they are found in the triangle ARC. The two triangles, they make the whole. Let me show you. Maybe if I color here the triangle ARS. If I color the triangle ARS, there is S here. And then I color this other triangle this side. Let me use a different color. This side, RSC. You will notice that the triangle blue plus the triangle red, they make this big triangle ARC. That is going to be a key element when we solve this problem. Watch out. I'm looking for 2.2.3, which is the area of triangle RAS over RSC. I'm going to say this is the same as the area of triangle RAS, RAS, times, now I involve this big triangle, area of triangle ARC times, okay, I say area of ARC divided by area of RSC, triangle RSC. If you observe carefully, guys, this, what I've just written here, is not different to the statement of 2.2.3. Because if we say this guy, area of ARS, if we were to cancel, in this case, it won't be a good idea to cancel. If we were to cancel this guy and this guy, you will notice that actually what I've just written here is the area of triangle RAS over the area of triangle RSC. Let me show you in a simple context. 2 over 5. I can write it as 2 over x times x over 5. Knowing that x cancel x, this is 2 over 5. So this is the strategy that I've used today. But the key idea is that I wanted to involve the big triangle ARC. Now, look at the triangle RAS and the triangle ARC. I'm going to erase everything. They have got a common angle. The triangle RAS, this triangle, and the big triangle, they are having a common angle, which is angle A. So I'm going to see this angle as my included angle. So when I calculate the area of triangle RAS, I think I will need a space. Guys, let me just take this information from here to here. So I'm going to say area of RAS is going to be half of, if A is the included angle, this two sides, I have to involve this two sides. So I'll say half of AR AS sine A. Okay, over. Now I'm looking for the area of triangle ARC. Remember, A is here, R is here, C is here. I'm just see this A is still the included angle even in this big triangle. So now I'm going to focus on the side AR and the side AC. So I will say half of AR times AC sine A times this is this. So now I'm going to this. If you observe carefully the triangle ARC and RSC, let me go back and erase everything here. You'll notice that they have a common angle. If you look at ARC and the triangle RSC, they've got the common angle which is C. So it means I will have to change the side I'm focusing at. Let me do this. When I'm looking for the area of ARC, I will say half of, since C is my included angle, on the big triangle ARC, I'm going to take AC and RC, which is the side between the included angle, and say sine C. And say half of, now I'm going to the small triangle RSC, half of, there I can take RC, SC, sine C. Yes, and then now let's see what happens after doing this. Half cancel half, AR cancel AR, sine A cancel sine A. We're left with AS over AC. What am I doing? AS over AC times half cancel half, RC cancel RC, sine C cancel sine C. So I'm left with AC over SC. And we see that AC cancel AC. So I'm left with AS over SC. Okay, so AS over SC, it has been solved on 2.2.1. I forgot what was the answer for AS over SC. I think it was something like 3 over 7. So it means AS over SC, it's 3 over 7. You will check the answer for AS over SC. We know it was calculated on 2.2.1. So which means that we have solved the problem of 2.2.3. It is AS over SC, which is 3 over 7. So this was the interesting question of Euclidean geometry, where we talk about proportionality theorem. I will treat a different question now on question number 3. So I have to end this one. I will make a different video. Just look for it on my YouTube. Okay, the reason I'm not just going boom is because as human being, we are getting tired. I need to get water and then come back after some time. Maybe after 5 minutes, I'll be back dealing with question 3. So please come back and check question 3. Thank you so much. Please, can you please subscribe to my YouTube channel and click that notification. Don't only subscribe and go. The problem, you guys, I've noticed some of you come only for the assignment. Please, you can learn from the YouTube channel. So there are some videos which I've made that you can learn from. Thank you so much. It's nice having you. I'm hoping you are here on the academic world by Impatelity TL. Thank you so much.